Okay, in this class, let us see an interesting topic. It says area of a parallelogram in terms of cross product. That is, we'll be taking magnitude of the cross product. Okay, now all of us know that cross product of vector A and B, we'll write it as AB sine theta. Okay, and if you know that the result of cross product is a vector, you can write it as vector C, and this will tell you the magnitude, and for direction we'll write c cap. Okay, c cap is in the direction of vector c, like that. All right, now if you just focus on magnitude, okay, now if you just focus on magnitude, you can write the magnitude of A cross B. Okay, it is simply A B sine theta. What is the magnitude of B cross A? It is same as AB sine theta itself. Okay, so remember, I'm just talking about magnitude. All right, now what we do is we will consider the vectors A and B. Okay, pay attention, the vectors A and B, will consider them as the sides of the triangle. Okay, we'll sides of adjacent sides of a parallelogram, not triangle, sides of adjacent sides of a parallelogram, and we'll say the angle between the vectors is theta. All right, now the same thing we had done for finding out the resultant, correct? Fine. Now here, say O is the point where the tails of the vectors are meeting. All right, now we will try to express in this discussion, in this class, we'll try to express the area of this parallelogram in terms of the cross product. Okay, so that is the whole idea. Now let us complete the parallelogram. All right, so this is the side opposite to vector A, so I'm writing it in red color. So this is the side opposite to vector B. All right, now we got the parallelogram. All right, fine. Now if you look at the area, how to find out the area of parallelogram, right? So the area of parallelogram is given as base into height. Correct, it is given as base into height. So yeah, here what we can do is base, right? So base for this parallelogram, you can take it as A. Otherwise, you can imagine the parallelogram is resting on the yellow side, then the base will become B. All right, now if it is resting on this base A, then height will be given by this. Okay, now let us say this is the height. Okay, so this is the height. All right, so this is the height h. All right, now let us, so the perpendicular distance between the two sides, right? So that is h. Okay, so these two angles are 90 degrees. Okay, now let us name this point as the point where this h is meeting vector A, or you can treat the vector A as line for now. Okay, because we are simply calculating the area of the parallelogram. Okay, so this point, let us call it as x. Okay, now say this point you can call it as y with respect to the parallelogram. All right, now you just have to treat this line. Okay, so if you name the parallelogram, you can call it as O A B, no, not A, so you can take O P Q Y. Okay, so O P Q Y is our parallelogram. Okay, now in that you have four sides. All right, all of us know the property of parallelogram, right? Opposite sides are equal and parallel, right? Now this vector A, whatever you are saying, just consider its magnitude. We know that the length of that vector will give us the magnitude, right? So just focus on the length. All right, don't worry about the directions for now. Fine. All right, now here base, right? Now what we can write for base is simply magnitude of A. Remember, I'm just taking the length of the vector, so this is magnitude of A. Okay, so base I'll write it as, base I'll write it as A. Then height. Okay, now I need height, so this pink line, right? So h, what do I write? How do I get? So if you focus on the triangle OXY, correct? If you focus on the triangle OXY, and if you try to write sine theta and cos theta, theta is that blue angle, whatever you are saying, you will find that OX, right? So OX is actually B cos theta, and this h will be B sine theta. Okay, this h turns out to be B sine theta. All right, so therefore I'll write it as A multiplied by B sine theta. So what did we get? Basically we got it as AB sine theta, correct? AB sine theta. So finally you can write area of parallelogram is equal to AB sine theta. Now as you can see from here, What is AB sine theta in terms of cross product? It is the magnitude of cross product of vector A and B. Alright. See, the question goes like this. They'll say two vectors are in a place and the angle between the vectors is theta if they represent the sides of the adjacent sides of a parallelogram. Means what? You just have to consider the length of the vector, okay, the magnitude of the vector, that is all. Alright, so AB sine theta, it actually gives you the magnitude of the vectors A cross B. Okay, remember we are only dealing with magnitude here. Alright, so if two vectors are which are making an angle of theta, and you can say the angle between the vectors is theta, and if the two vectors represent the adjacent sides of a parallelogram, then the area of the parallelogram can be given by this expression. Okay, so that is all. Alright, now there is one more way. What if diagonals are given? If diagonals, or you can say if the vectors, okay, if the vectors represent diagonals of the parallelogram, okay, if they represent the diagonals of the parallelogram, then what is the area? Okay, what is the area in terms of the diagonals? Okay, we'll try to find out that. All right, now this is easy again. So what we'll do is we'll consider two vectors, so say P and Q. Okay, now we have vector P. Yes, now we have vector P and say this is vector Q. Okay, now arrange them, shift them. Okay, so shift them. So if you shift them, you can say the angle between the parallelograms is theta. We need this. Okay, we need the angle angle between the vectors, not parallelogram. We need the angle between the vectors. All right, angle between the vectors, say it is some theta. All right, fine. Now we have to consider these vectors as the sides of diagonals of a parallelogram. Okay, that is what it says, right? Now let us keep P here. Okay, so this P is here. Now, okay, we are simply shifting, right? So say we are shifting this Q also. Okay, we have to make it look like parallelogram, right? Now what are the properties of diagonals in a parallelogram? Means what we know. So we know that the diagonals of a parallelogram, they actually bisect each other, correct? So they actually bisect each other, and if you can see this theta, right, now this theta will neatly fit here. Okay, so there is no change in this angle. Okay, so we are simply shifting. See, we did not change anything, right? Okay, fine. So this will be the same theta. I suggest you to draw two separate diagrams. All right, now what we'll do is we'll complete the parallelogram. Okay, remember P and Q are the diagonals of the parallelogram. Okay, now if you complete the parallelogram, so this is what we get. Okay, this is not, yeah, now it is bisecting, I think. Fine, so I'm completing the parallelogram now. Okay, please draw neatly using your scale and pencil. All right, now let us name the parallelogram. Call it as A, B, C, D. Then this can be O. Okay, this the intersecting point of the diagonals. You can call it as O. All right, now let me write this angle theta a bit smaller. All right, so this is our angle theta. Okay, this is angle theta. All right, fine. Now now I have to find out the area of the parallelogram in terms of the magnitude of the diagonals. So the diagonals are actually vectors here. All right, now again, so let us see here. Now we have to go to the properties of parallelogram. All right, now we know that we have two triangles here. You can say triangle ADC and triangle ABC are congruent, right? Are congruent triangles. Okay, and you know that the area, right? Area of area of triangle ADC is equal to the area of triangle ABC. Okay, is equal to the area of triangle ABC. So this is a known fact, correct? Fine. Now what we'll do is, now observe this triangle ADC, right? Now somehow I have to find out the area of the triangle ADC, and we also know that the area, correct? So area of parallelogram, okay, area of parallelogram, what is that? ABCD, that will be twice the area of one of these two triangles, because both the areas are same, right? So that is equal to 2 times the area of, okay, area of triangle ADC, correct? 2 times the area of triangle ADC. Okay, so try to write parallelly, all right, in your notes. Then now what we'll do is, we will drop a perpendicular. Okay, we will drop a perpendicular from this point D onto the orange vector P. Okay, so say this is the perpendicular. Now the angle what it makes is 90 degrees. All right, now call this point as some point A, B, C, D, E. Okay, this point is point E. Okay, that point is point E. I hope you can see. So this point, okay, now this point is E. Please write in your notes. All right, now this triangle ODE, right? So this triangle ODE, it's a right angle triangle. Okay, now you can clearly see that OE, right? So OE, it will be OD. Okay, OE will be OD cos theta. Okay, and this DE, right? So this DE will be OD sin theta. Okay, now OD sin theta. Now coming back to the properties of this diagonals of parallelogram, right? So we know that the diagonals will bisect each other, right? Now DB, correct? So DB, if you look at it, it represents the magnitude of this vector Q, is it not? DB, it represents the magnitude of vector Q, and AC represents the magnitude of vector P. All right, so you can say DB, it represents magnitude of vector P, and AC, okay, so AC, it represents magnitude of vector Q. Okay, AC represents magnitude of vector Q. Now you know that OD is equal to OB, okay, because just now I said it will the diagonals bisect each other, right? So you can say OD is equal to half of DB. Okay, so therefore OD technically represents half of the magnitude of vector P. Okay, it represents half of the magnitude of vector P. Okay, so consider this, if I simply write P, it is telling you that it is magnitude. All right, fine. Now I need the area of the triangle ADC. What can I write? Half into base into height, right? Now base is AC, height is DE, correct? Now area of triangle ADC is equal to half into AC, correct? Half into AC multiplied by DE, right? So half into AC into DE. All right, right. Now what is DE now? DE is actually OD sin theta. Okay, DE is OD sin theta. So therefore I can write half into AC into OD sin theta. Okay, now let us substitute. What is AC? AC is magnitude of Q, correct? Simply I'll write Q. Now OD is P by 2, then sin theta. Okay, yeah, we have the answer here now. So you can write, so this is 1/4 of PQ sin theta. Okay, 1/4 of PQ sin theta. Remember, this discussion is not same as this one. Okay, because here we consider the vectors as the adjacent sides of the parallelogram, right? But here in this case we have considered the vectors as the diagonals of the parallelogram. All right, fine. So next you can say, therefore area of parallelogram, okay, so that is 2 times the area of triangle ADC. Okay, 2 times the triangle area of triangle ADC. So this will be 2 times 1/4 PQ sine theta. So what did we get? Finally, we have half of PQ sine theta. So this will be half of, now PQ sine theta, you can write it as magnitude of P cross Q. Okay, so these vectors P and Q, they actually represented the diagonals of the parallelogram. Okay, fine, right. Okay, so please do this in your notes once. All right. Yeah. Okay, if you want, you can take an example here. Yeah, for this case, the vectors, they say like this. So you have vector A. Okay, vector A is 6 Newton. Okay, then vector B is 3 Newton, and the angle between them is, say, theta is 60 degrees. Okay, then they'll say, what is the area of the parallelogram? So what will you write? So area of parallelogram is magnitude of A cross B. Okay, so they say if these forces, the question will be like this, if these forces represent the adjacent sides of a parallelogram, so what is the area of that parallelogram? Okay, so area of that parallelogram will be, so magnitude of A cross B. So it's simple. So you can say this will be A B sine theta. So this will be 6 into 3 into sine 60. Okay, fine. So that's all. So we'll get it as 18 root 3 by 2. So that is 9 root 3. You can say, yeah, 9 root 3 is the magnitude. Fine, right. Units you can write. Fine, okay. So like this. Then the next case, you can take your own example if you want. Okay, I hope you got the concept here. All right, fine. All right, now let us see in the next class. Yeah, I'll be sharing few materials with you. Okay, so please go through the materials. All right, now in that there are few concepts, right? So as I told you, this vectors, right? So this vectors chapter whatever we dealt so far, it is the basics, right? But there are, you may find questions which are from chapters of class 12. Okay, and the concepts which you haven't studied till now. All right, so don't worry about those type of questions. So whatever concepts have been covered in this video so far. All right, so try to answer the questions which comes under that. All right, so if you are facing any problem, please you can WhatsApp me. I'll help you in solving. All right, now in tomorrow's class we will do a bunch of problems again, starting from the first concept onwards. All right, fine. So I'll try to take the problems from the materials whatever I have shared with you. All right, now you try to do few examples from that as a homework. All right, fine. Okay, take care.